Hello, welcome to the video notes for lesson 5-12. These notes begin on page 64 in the notes packet. This is about, this lesson, writing equations of lines from word problems with initial value of 0, 0. Remember, we've talked a lot about this value and where it comes from. It's the origin of the grid. So, our learning targets are, there's two of them, write an equation of a line given slope and a point on the line, and write an equation of a line given 2 points on a line. So, same learning targets as the previous lesson, but we're going to apply them a different way. Okay, so, and remember, we're going to be dealing with word problems, so you may need to use your Bucks skills and strategies here to help you organize your information. So the first problem, the graph shows the distance d a car travels in time t at constant speed r. Write a linear function rule to model the distance d a car travels after any number of hours t. Now, if any of you are not aware, there is something known as the distance formula. And the distance formula is d equals rt. Now, d stands for distance, as it says in here. T stands for time, and r is the speed, or the rate. So what we need to answer this question is we need the rate. Now, if we think of our equations that we've been doing throughout this unit, they look like this: y equals mx plus b. If I were to erase or cover up the plus b, my equation y equals mx looks a little like d equals rt, only with different letters. That's because it is basically the same thing. And the reason why these are identical is because this, if you look at the graph, starts at 0. So if our y-intercept is 0, we're not going to write plus 0. So that's why it's just y equals mx. But in this case, we're going to use d, r, and t. Now, if you want to think of y equals mx instead in finding m, okay, that's probably going to make the most sense here. We're going to find m, which is the change in y over the change in x, our rate. So, y is changing by going up by 30 each time, so plus 30. X is changing by going up by 1 each time, so 30 over 1. So the rate, or the speed, is 30 miles per hour. Now, if I was using my other form, I would do y equals 30x. But since I'm using d equals rt, I'm going to replace r, that's my m in this case, with 30. So d equals 30t. And there's your equation for this problem. Now, I only needed to use the d, r, and t because in the word problem, it gave me those variables, those letters. When they don't give you any, or in most other situations, we'll be using our y equals mx plus b. Alright, so the next problem. Mr. Dietz can type 180 words in 4 minutes. Write a linear function rule to model the number of words typed y in x minutes. So we know y is equal to the words, and x is equal to the time, the minutes. So there's our input and our output. Remember the form that we're going to be seeing here, y equals mx. Now, because it's starting at the origin again, it would be plus b, but since b is going to be 0, it's just going to be y equals mx. So I need to find my m. M is going to be equal to the change in y over the change in x. So since it would start at the origin, it's going to be, if I want to think of a mini table here, it would be 0, 0, and then my time, x is 4 minutes, my y is 180. Now some of you won't need to do the table, some of you will recognize that what we have is 180 over 4. And if you find the unit rate, divide or simplify, you'll get your answer. And 180 over 4 simplifies to 45 over 1, or 45, and I'm going to do WPM for words per minute. So what's my equation? Well, I have my rate, my slope, my rate of change, that's m, 45, so y equals 45m. And what's nice is, now, oops, mistake. What's nice is, if I give you any number of minutes, or if I give you any number of words, you can figure out from this equation the input or the output value. I'll give you an example. So, if anybody can answer this question and share it in math, you will get points on your scoreboard. How many minutes will it take to type 495 words? So, 495 words can be typed in how many minutes? And you can use your equation if you know where to substitute it. Alright, on to the next problem. Mamma Mia's Pizzeria sold 37 pizzas and made $550. Write a linear function rule to model the amount of money made, A, for n number of pizzas. So, the amount of money made, that's your output. So y is going to be A in this situation. And for n number of pizzas, n is going to be your input. So we're going to use y equals mx. We're going to find m, and then when we're done, we're going to replace y with A and x with n so that our equation models or fits the description here. Now to find m, I'm going to do change in y over change in x. If you want to do a mini table, go ahead. I'm just going to do 555, change in y, over 37. And when I simplify that, I get 15 over 1, which really stands for $15 per pizza, per one pizza. Alright, so now plug the 15 in for m, you get y equals 15x. But since we defined our variables, we're going to replace y with a, we're going to replace x with lowercase n, and there is your final answer. If you left it y equals 15x, I wouldn't take any points away, but I would let you know you should use the variables that they give you. Okay, another star question here. How much money will Mamma Mia's make if they sell how about, let's go a big number, 55 pizzas. 55 pizzas will make them how much money? Use your equation to figure that out. Okay, on to the next page. Page 65. Okay, so I'm going to do one of these with you, and I'm going to let you try to do the other one on your own. I'll help you set it up, because this video is starting to get a little long and we got to wrap it up. At time t equals 0, a bicyclist begins riding at a constant speed. 10 minutes later, the bicyclist has traveled 2.5 miles. Write the linear function rule that models the distance, d, the bike travels after any number of time, t. So remember, we're going to be using y equals mx as our model. But this is really a D equals RT problem. We're going to be finding R, which is the same thing as M. It's our rate of change, our slope, okay? They tell us the time is starting at 0. So let's do a mini table for this. That means our distance is 0. So then we're told that 10 minutes later that the bicyclist has traveled 2.5 miles. So change in Y, actually that is a mistake. That should not be 2.5. That should be 25. Although that's pretty fast. Because that would be, yeah, no, 2.5 was right, sorry, 2.5. So 2.5 miles in 10 minutes. So change in Y over change in X. So this is going up 2.5, this is going up 10. So change in Y over change in X, because I'm trying to find my M, equals 2.5 over 10, which I know this is a decimal, and we don't really like decimals in our fraction, but I do want to simplify it to a unit rate. It's 0.25 over 1, that's a quarter mile per minute. That is going to be our rate, 0.25 miles per minute, okay? And we're going to substitute that into our Y equals mx, 0.25x, but they gave us d, r, and t, so we're actually going to rewrite it one more time. D equals 0.25 t. There is your answer. Okay, the next one. At time t equals 0, a bottle machine begins to produce bottles. So let's go 0, 0. After 6 minutes, the machine made 150 bottles. That's the 0.6150. Write a linear function rule that models the number of bottles n after any number of minutes, t. Alright, so I'm going to help you set this up, and you're going to finish it on your own. Couple things to point out. Our y is really going to be turned into n, and our x, our input, is going to be time. So we're going to be finding change in y over change in x to get our equation. I've given you 2 points. I've set up a table. You should do the same thing. Find the rate and then plug it into the equation. We'll see who can figure this out. Good luck. If you had trouble with this, go back and rewatch the video or come and see me for help, and we will see you in math.